few days ago, I wrote this article about how to make exponential growth predictions using coronavirus data. And it's on datablends.us, and I've had some questions about the growth factors and how you could do some more in-depth modeling. So I'm going to add a little bit more detail to this. So if you go to datablends.us and go to the series, down here there's math modeling in Tableau. If you click that, there's a number of articles I wrote back in 2013 and 14, including the first 3 of them are linear trend models, all the Tableau trend models, and additional insight on exponential trend models in Tableau. But I'm going to show how Tableau can be used to with this data. So if we look at where we are today with the data from Johns Hopkins website, we can see that through 3:30, the projection of the millionth case now is down to April 2nd at 5:30 a.m. The first time I did the projection back on 3:20, it was on April 5th. So that has changed over the course of 3 days and coming sooner, which means that there are more cases being established worldwide than there were back at 3:20. So if we look at that, here's the series of exponential growth models that were best fit curves to the data that we had at those different points in time, starting on 3:20, 3:22, and so on up to today. And so here's the projection on the 5th of the first projection at the millionth case, and now we're over here on April 2nd, early in the morning. So that's what it looks like. Now let's get down, take a look at some of the details. So here's the data from the days through today, and here's the growth function that I showed before, which doesn't tell you anything about the actual exponential model that's created. So what I did was I plotted in here the raw data shown in blue with all of these cross bands like this, which are uncertainty terms. And then what I did was I took this model, which is y equals c naught e to the alpha t, where alpha is the growth term, and we can see that it's 0.1037. So I took that slope, and actually with a little bit more detail here from Tableau, as I'll show you in a minute, and then I calculated e to the slope times time. So each one of these terms here is just simply taking e to this number times the number of elapsed days in this column. And so then to get the total number of projected cases, you take your C naught times this function. Now, C naught in terms of our very first data point is 128,000. And if I put 128,000 in there, what we'll see, 343, is that these curves separate a little bit because we're matching the first data point only, and then we're doing the projection beyond where the data is. So you could see that that's not the correct C naught. So how do you get the correct C naught? Well, let's jump over to Tableau. Tableau has the same data shown here in blue. This is the actual data points. And you can see that the exponential curve fit for that, if I display this trend model, we can see that we have a slope, as I already mentioned, of 0.103646, and we have an intercept of minus 4538. So if you took this all the way back to time 0, that would be your intercept. But for our model that we're dealing with here, we're using the first data point as where we're tying the models together. And we can see from this that this is the actual data point of 128,343, but the actual exponential model is predicting more like 120 because we have a little bit of we have some overshooting and some undershooting, and that's what happens when you get a curve fit like this. So I'm going to put in 120,000 in there to shift this curve into position. So if I take this value minus 8,000, I have to make it a formula. Let's just make it into a formula. Our initial position minus 8,000 because that's what we saw in Tableau. Now we see we have the right curve fit for this particular model. And when we plot the actual measured cases versus the predicted cases using this exponential model, we can see that we have a 99.9% R squared. And so this is how you use exponential models, where you have the curve fitting to it. You get this curve fitting, and this is the curve fitting from Excel. This is the curve fitting from Tableau. They're exactly the same numbers. And if I put on the predicted cases, you could see them. Here they are. They match perfectly in Tableau like they do in Excel. So if you're doing this in Tableau, just make a edit your trend line, make it an exponential, and then when you look at describe the trend model, the terms you're looking for, the primary term you're looking for is right here in terms of the value. Now you do need this to be in terms of hours. You need your time in terms of hours because the data is at the level of hours. If you put the data at the level of days, for example, you change this to a day, then you're going to see you get a much more coarse curve fit, and that's not what you want. So take off the predicted part. This curve fit is obviously at the wrong level of detail, and if you were to describe your trend model with that, you're going to have a completely different slope of 0.101. Well, it's not completely different, but it's not as accurate as going by the hour. So anyway, that's those are some of the things that you need to think about when you're doing this in Tableau. We could even go by the minute and still get the same curve fit. In fact, I can prove that. The trend line, if we describe that, that's going to have the same type of slope, 0.10372, very close to what you get for the hour. So that's how you use curve fitting in Tableau and Excel if you don't want to use the growth function. Thanks for listening.